Okay, so I'm starting to record now. All right, everybody get comfortable. Today's just going to be me going over the practice exam. You should have gotten an email about what to expect to be on the practice exam. Mainly for loops. There's going to be other stuff than besides these things, but the primary focus is for loops. The primary focus is turtles and a little bit of slices. Not anything more complicated than what you see over here. Because again, I try to do harder things on the practice exam. This exam is meant to be as close to I can make a paper exam while still making it on the computer. So that means that basically no resources no running your code, no resources on your computer other than just literally having Canvas open to this page to take the exam. With regards to notes, I'm a firm believer in preparation, so as long as it's on paper, anything is allowed. Okay, if it's on paper, it's allowed. Basically, that's the note policy. So if you want to and this is just to make sure that I don't have to deal with any complications with you pulling up your code to reference your code, right? Because if you're pulling up your code to reference it, it might open an idle, which may give me the wrong idea. We don't want that to happen, so if you want to reference your code, please print it out. So, you can bring as much paper as you want. Just be careful. You might have issues getting a wheelbarrow through the, so no restrictions on the amount of paper. Yes. Sorry? Okay, that's actually a very good question. What would I recommend bringing for your notes? All right, so if we can get a bit of quiet here so I don't have to use the microphone to speak over you. The notes that I would recommend for bringing for the quiz, I would recommend printing out, if you need a reference to them, the turtle functions, just so you don't forget what they do. Same with the list functions, or the string functions, because while I'm not going to be testing you on list or string functions, those are things that may be able to help, give you a shortcut. I don't intend to have anything in there that can be easily shortcutted like that, but if it's legal code, if it's code that would actually run, then it's all good. I would also make sure you do remember your order of operations here, because I will ask you some questions on that. The other thing is that part of the reason why I'm not letting you use idle during this exam is because there's not enough time for you to use idle, and that doesn't sound like that makes sense. But you cannot write nearly as quick. You cannot right now where you're at. You will write slower on an editor like idle than you will on paper or in just Notepad or something. This is because once you start running, because in idle you'll test your code, and then you're going to run into all those little errors like forgetting a semicolon or something like that. Whereas if you're just typing it in here and you forget a semicolon, I'll just mark it, maybe ding you a point and move on, Whereas that can be like a 10-minute time sink just trying to figure out what the issue is. You haven't had the chance to make those mistakes enough to automatically correct them. So that's part of the reason. It allows me to ask a few more questions than normal. Now, this exam was a practice exam that was much, much longer and somewhat harder than the actual exam, and the actual exam had a time limit of that time for 2 hours. The exam that I'm writing currently, of course, has a time limit of 1 hour and 20 minutes, the entire class session. What if you need more time? Refer to the syllabus. There's a late penalty if you turn it in. It is a very lenient late penalty, so nothing to get you anxious about. So basically it amounts to every 10 minutes late is a point off. Okay? So that's actually quite generous if you think about it. You can turn it in 1 hour late and that's still, But please don't subject your TAs and me to that, where it's just simply so that there's some balance between taking a few extra minutes to finish a question versus making sure that students don't get overly anxious about the time limits. Also, this is less relevant on an electronic exam, but the amount of space that I give you for a problem has nothing to do with the difficulty of the problem. It has everything to do with organizing the page for the problem. So 2 points here for exams. I have a friend, one of my best friends who now works for Google, and he did a PhD with me. He loved saying that every question is an essay question, including the multiple choice questions, which is to say that basically some questions are sometimes poorly written. I do my best to not write bad questions and not write ambiguous questions, but sometimes I mess up. If I do mess up, and you can ask me for clarification. If for some reason you cannot ask me for clarification, just because you can't get my attention or you're too embarrassed or whatnot, write down your assumptions. Okay, write down the assumptions. Don't make me second guess your assumptions. Okay, but write down your assumptions. You can clarify any answer you give. Allowed to ask for clarification. We'll see that any math that I do here is going to be fairly basic. You shouldn't have to use a calculator for any of these. If it looks like it's going to be complicated, then the answer is as follows. It's either positive 1/2, positive 1, 0, negative 1/2, or negative 1. That's not just true for this class, but also for your physics classes. Professors love being able to easily check answers. So having an answer that is, easy to check, is good. Leaving questions blank, I can't give you points for blank questions. I can give you points for some, vague scribbles about how you would solve this problem, but you can't quite put it into code. I can give you some amount of points for that, for problem solving stuff. And of course, don't panic. So this goes back to the first lecture. Like, when did we learn this? All the way back in the first lecture. So computer science is the study of computers, true or false? As false. Computer science, there's lots of definitions for computer science. I'd say a not wrong definition is that computer science is the study of algorithms. There's a lot of formal ones, but that's just a heads up. You might want to go back to the first lecture. Alan Turing is often considered to be the first programmer. False. That is Ada Lovelace, and that answers the second question: who was Ada Lovelace, and why was she an important figure? She was often considered to be the first programmer. I would check your first lab, by the way. That's my hint as to for your history question. I would check your first lab, and be prepared to know the thing from your first lab. Okay? So this one, you'll probably not get 10, maybe 5 of these questions because, but why I would give you 10 here because they're fairly easy and quick to answer. So what would each of these following expressions evaluate into Python? I know it feels like I'm just bombarding you with these random social media posts like, 90% of people can't get this one right, No, just, again, those often rely on ambiguity, and none of these have any ambiguity because they're typed into a programming language. So here, remember your order of operations, which is that multiplication and division have the same amount of precedence. You just go left to right. So here it is 2 times 3, which is 6. Then we divide by 6. So that becomes 1. And then 1 times 100 is 100, right? You can trivially check the answer for all these by just pasting them into Python, of course. 1 mod 2 plus 3 mod 2. This one is, again, trying to remind you what is the precedence operator for the modulo, And modulo is a division operation. It's asking what's the remainder after you divide by 2 in this case. So those modulo operations come afterwards. 1 mod 2, what's the remainder of 1 divided by 2? It's 1. What's the remainder of 3 divided by 2? It's also 1, right? Go back to fourth. go and cast your memories back to 4th grade to remember this. I know you thought those days were long behind you, but we do use the remainder here quite aggressively. So 1 mod 2 and 3 mod 2, that gives us 1 plus 1, so that's 2. This one is to make you remember what happens when we mix types. So the answer here is exactly what you would think, which is negative 11.5. But it's to remind you that, oh yes, we can mix types. We can do it if we have an integer on one side and a double or floating point on another. Double floating point, that's just the same thing. Python calls it a float. Other programming languages call it a double, because it's a double precision floating point number, but Python doesn't bother making that distinction. So what happens is that if we are mixing types, the -1 gets converted to -1.0. So this becomes -11.5. So it's just kind of reminding you about that. Here, this one's our first kind of not straightforward one that you have to actually remember order of operations, which is 3 times 2 goes off first, right? Because multiplication occurs first. 6, 4 plus 5 is 9, minus 6, so that would be 3. By the way, I haven't looked at these in like 6 months, so I barely any memory of them. So they aren't that hard to solve off the top of your head once you have the rules down pat. So let's see, 0 times some godforsaken number plus some other godforsaken number, right, added together. Let's not even bother doing this because 0, right, times anything becomes 0. So this entire expression ends up becoming 0. So our answer is -1.0, right? So don't bother doing, so if you know what the answer is going to be, right, you can skip those steps. And in fact, a smart compiler would probably skip that step too. Note that, hey, I'm multiplying stuff by 0. I can just not bother doing the math there. Right? So this one, again, straightforward, -12. You see a lot of these are why I'm going to say there's probably going to be 5, because I'm repeating testing on the same kind of thing. This one, 7 divided by 3 plus 2 times 3. So 7 divided by 3. Now this is divide, which means that it's integer division, which means we're dealing with quotient remainder, right? Here we're asking what the quotient is, again, but we don't care about any decimal places. So 7 is divided by 3 twice. Or 3 goes into 7 2 times, right? So if we were to write this down as, in our, like we've had to do in the past, we would go basically something like this, right? So it'd be 2, and then we'd write remainder 1. That's what you do with integer division, right? So this is what we care about. Okay? So remember, with integer division, we just the other way to, or if you don't want to bother, doing that, you can just skip a step like I do, which is you recognize it's going to be that the answer to 7 divided by 3 is going to be 2 point something, right? Right? It doesn't matter what it is, though, because I'm going to be discarding it, right? So that's 2 plus 2 times 3, which would be 6. 6 for the entire answer to be 8. That's what happens when you try to draw and type at the same time. All right. 4 modulo 2. 4 modulo 2 is 0, right? 2 goes into 4 cleanly. 4 is evenly divisible, 4 is just straight up divisible by 2. So that means there's no remainder, which means that the remainder is 0. So this becomes 0 times 3, which is 0. Okay, another one over here, big awful number divided by other big awful number. But this big awful number is much bigger, right? This is much bigger than that awful number, right? Now what does that mean? Well, since we're dealing with integer division again, well, a smaller number divided by a bigger number only ever has a remainder. So a small number divided by a bigger number only has to have a remainder, no quotient, so the answer is 0. And this last one is just to remind you that exponentiation exists, and it occurs exactly when you would think it does, which is that the answer isn't 10 to the fourth, it's 10 squared times 2, right? It's exponentiation. It's this is what that looks like in actual math. But again, we can't do superscript here. So this would be 200. Make sense to everybody? Any questions on this one? There aren't so much, I don't really consider these trick questions so much as quick questions that you can just kind of, where I'm singling you out to you, hey, remember this rule, this quirk about doing division in programming? Okay? So what about a question like this? Eight divided by 2.0. I'll make it very obvious here. 8 divided by 2.0. The correct answer in this case would be what? Yes? 4.0, right? Because it converts to a floating point. So the answer becomes a floating point. If you're interacting with floating points, your answer must be a floating point. If you forget that, but get everything else right, they'll probably just ding you a little bit on that, but you won't get the question completely wrong. So just keep that in mind. Okay. All right. So also down here, you don't have to worry about these because those are Boolean expressions, and I haven't gone over the Boolean expressions yet. I do believe, however, that they all evaluate to true because yes, I am that kind of professor. If they're supposed to be random, right? Any sequence of 5, any sequence of 5 that has a 1 in 32 chance of being all true and a 1 in 32 chance of being all false, and yet you think that it needs to alternate. No. Anyway. So what are the values of x, y, and z after the following statements? So we start out with x being 7, y being 8, z being -5. And you can kind of see now why I say don't run any code, because otherwise I don't get to ask you really, these easier questions that basically ask, can you read code? Then it becomes, can you run code? And I would hope the answer is yes for everybody at this point. So let's see. So x is equal to something, y is equal to something else, and z is equal to something else. So we can solve these independently of each other. X is equal to 7 plus 1, so x's value becomes 8. So x is equal to x plus 1. That's 7 plus 1 is equal to 8. We store 8 in x. So y is 8, z is -5, right? And now we have now we have y over here. Y is equal to x plus y plus z. That's 8 plus 8. That's 16 plus -5, which is just simply saying 16 minus 5. So that becomes 11. And then the hardest part, I would say, is this next part, which is z plus equals 1. Because if you're being careless, it's just very easy to make a very understandable mistake and say that the answer is -6. Because 6 comes after 5, but I mean, you're incrementing, you're adding 1. So it's not -6, it's instead -4. Again, that's one of those kind of understandable mistakes to make. Remember, this is a shortcut for z is equal to z plus 1. Okay? Again, don't worry about these so much, these. Although this one is very good information to kind of know about how that works. about that one, which is that, again, anytime that you've got a double on one side or a floating point on one side and an integer on the other, we just convert the integer to a floating point. All right, so slicing and range. All right, so which of the following, so what would each of the following evaluate in Python? Okay, so an apple a day, and then ascended eines smear swangbe, okay? I mean, I'm the one who wrote it, so anyway, A3. So that's A of index 3, 1, 2, 0, 1, 2, 3. So that would be A, okay? When you get questions like this, by the way, when it's asking you what the indexes are, I highly recommend doing what I just did, which is just simply writing the indexes up on top so you've got a visual guide. Also, if you haven't picked up on it, I use a monospaced font for everything, for all my code. What does that mean? That means that all characters take up the same amount of space. Okay? Why is that important? Well, that's so you can see, okay, a space, you don't have to guess how many spaces are in it. You can physically see it's 1 or 2 spaces. I'm not going to do something tricky like put in a bunch of spaces and have you count them. That's counterproductive and pedantic. But I mean, like, if it's not, but over here, like, I would maybe have to write it again if they were not monospaced. Okay, so now over here, 3 to 8. The slice 3 to 8 means take the character 3 at index 3, go up to, but don't include 8. So 8 is this space over here, so go from 3, but do not include that, up to 8, so that is apple. Like I said, easy to recognize answers. Now this one's a bit of a pain, but let's go ahead and see. So B negative 2. So interesting fact about Python. You can do negative indexes. Yeah, I love it. You think, oh, that's got to be an error if you're coming from another programming language. And this is part of this is I also use the exams to kind of emphasize things you may not have picked up on. I love this kind of feature in Python. So apple. So if I go A is equal to just apple over here, this is not what we have there. But if I go A is equal to apple, and I say A is equal to, so if I ask what A negative 1 is, it gives me E. It gives me the last thing. So again, the least surprising thing. L there for negative 2. So A negative 1 gives me the last character. A to the negative 2 gives me the second to last, because otherwise figuring out what the last character is a pain. Here's how you would have to do it if you couldn't do negative indexes. You'd have to say A is equal to length of A minus 1, and that just looks ugly. That just looks ugly. So you can do this. So you can do negative indexes in Python. Java, unfortunately, you can't do that. So we have to suffer there. So B negative 2. So that means that B negative 2, this would be negative 1, this would be negative 2, right? So that would be B. A is A index 3. Well, we solved that already. That was an A. And then, okay, from 1 to the end by negative 1. Okay. So here's, again, again, this is what I mean by these things are more difficult than I would actually put on the exam. Okay. So a slice operation has start, it has end, and it has step, right? You have to have the start to end, or, well, actually, you don't have to have any of those points. You just have to have the colon from start to end to make it a slice. But you can leave out any of those points to say from the very beginning to the very end. But in this case, what the heck is the end? Well, we're going backwards, so the least surprising thing is that the end is the beginning. So start from 1, go until it ends -1. So start here, go backwards, NA. Okay? And then times 2. Times 2 does replication, which means that this is just simply we repeat NA. So our answer is banana. So this is what I mean by the fact that like the problems are going to be more complicated here than on the exam, because I want you to basically get a good mastery of these things. Now let's go to something less scary, okay? From index 1 to the end, up by 2s. That means from the beginning to the end, up by 2s. So we start at this one. So I'm going to underline the ones that are part of it. So index 0, 1, 2, D, D, E, N, space, M, E, S, S, A, G, E, which if you, I'm skipping every other one, which comes out to be hidden message. All right. So now this one's, I feel, is fairly straightforward, which is complete the following function. The function takes in a string argument text and prints the string in reverse. So if I do have you write functions, it's going to be please fill out the function, right? Does that make sense? So I try to keep the amount of writing you have to do to a minimum because, again, it's easier for you to read stuff and tell me what the answer is rather than for you to check stuff off. You'll find that the other exam and the final exam, like for the final exam last semester, I had 5 short questions and then you picked 3 out of 5 big questions because those questions were, fairly large tasks, but I wanted to give you time to do them. So functions takes a string and prints it in reverse. So there's a lot. So this is one of those questions where I want to emphasize there's a lot of ways to do this, okay, to print it in reverse. So first off, if you know your slices, you can do this basically in one step. Print, assuming I can remember how to write, okay, print text, and then slice from the beginning to the end, -1. That's actually a shortcut to say, take this collection and put it in reverse. Take this sequence, put it in reverse. So that does that in one line. If you know slices, it can be very advantageous. But what if you actually, want to do it as a for loop, like I would expect you to do? In that case, there's a lot of ways to do it as a for loop. There's actually a ton of ways to do it as a for loop. And I'll type it out simply because it's quicker for me to do the typing here rather than writing and having to erase, because I'll be erasing quite a bit if I have to do that, if I have to erase. So first off, let's go ahead and let's see, desktop. Let's see. Print reverse. Okay. So over here, def print reverse takes in some argument text, right? And what we're going to do over here is that it's fairly there. So first off, I would expect you to use a for loop. So there's a couple of different ways to do this. First way is that we could use the print function and modify the print function to do what we want to do. So for in range, so we'll figure out the range in a second, but what we would do, rather than blank, for letter in range, print the letter, right? So if I did for range, so if I did this for letter and text, print, okay, give me a second, print hello, right? This isn't too bad, you would think. Okay, so first off, it's printing out everything on an individual line, right? We don't really want that. Okay, so we could do we could do what we've learned here and say end is equal to nothing. So when I print it out, it's not gonna print out on a new line each time. But again, that's kind of minor thing. I'm still going in it in the way I don't want to do that. So there's a few different ways I can do that. First off, I can do the slice like I showed. The other way I can do it is I can go by the index. For index in range, index in range 0. Sorry, let's go with, so the range is 0 to length of text. Don't copy this down, it's wrong. Okay, I'm just kind of showing what we can do here. Okay, and now we switched it to this. Okay, but still going the wrong way. So if I wanted to go the right way, then the range needs to be reversed, like we learned how to do in the first problem of Lab 4, which is I'm going to start at index -1 at the last index, okay, and then I'm going to go down to -1 because remember it doesn't we exclude the last one, and then we have the third argument, -1, which means rather than going up in our indexes one by one, we're going up by -1 or down by 1, I should say. And there we go, we get OLE. Okay, so that's one way to do that. Another way to do that, by the way, is that we could use an accumulator. Okay, so we could say reversed, is that a hint? Yes, that is, but we'll come back to that later. Reversed text is equal to empty string, and what we could do is we could do something like this. We could say for each of these things that gives out the correct answer is correct, by the way. For letter in text, actually I'll keep it like this. Instead, I'll keep it in this and then I'll show the other one. So, okay, for index in, yep, there, and now we just simply do reverse text plus equals the text at that index. Okay, and then we would have to print it out at the end. Print first text. There we go. And then another way we could do that is that what if you really are uncomfortable of going in reverse, right? Did the idea of going through your indexes in reverse really bothers you? Well, we can switch this up one last time. For letter in text, what we do is that if we were to simply add like this, plus equals letter, right, that's going to be the incorrect answer, hello. Now this is short for reversed text plus letter, which says take what we have and add letter to the end of it. But instead, if we switch that around and say letter plus reverse text, take what we have and add the letter to the in front of it, we can just do a normal loop here. All these ways are equally correct, okay? They would all receive equal credit. Finally, the last thing was, yes, there's a reversed function just built in, reversed, which gives you a list or a string reversed. It's kind of useful. That would also be correct. Because, again, what I'm testing here is your mastery over the material, and knowing those kind of things is, I consider, fair. All right. So now to get to our turtle questions. This is very kind of our very common question, kind of thing. This is probably the only time you'll hear me say, but some of these questions you may end up using your phone on them just simply to take a picture of what you draw or whatnot. Or you could draw it on MS Paint or whatever drawing program on there. Or you could take a piece of paper and draw your answer on it and take a picture of it and upload it to the exam. I'm fairly flexible on these things. So don't work. So again, but anyway, this is the kind of question I like to ask. But I'm probably going to make it a bit easier on us and just simply say, hey, draw the result. Rather than asking you to draw the result, I will give you a multiple choice question that says, hey, select which one of these is correct. So here's our function. We import turtle. We set up our turtle, Bob. And then the important thing here is that we set up Bob and 5, okay? So over here, we've passed in 5 into length, which means that basically whenever you see a length, that should be a 5. So this says, repeat the following 5 times, right? So which is to say, Bob starts facing facing this way, so he should turn right 45 degrees. Okay, and again, the distances don't matter really so much as long as they're relative to each other, right? 10, 100, it doesn't really matter so long as they're equidistant. But anyway, Bob, right 45, forward 10, left 90. Sorry, I went the wrong way. Got my rights and left confused. I swear I passed kindergarten. So Bob is facing this way, which means 45 goes this way. So you go down this way, forward 10. That's what we go down. Turn left. That means we face this way if we're turning 90 degrees, right? That's a 90-degree angle there. Well, something approximating it anyway. And then forward 10. So go forward and equal now. And then right 45. So we went 45 and 45 in one direction, and then we went 90 in the other direction. So our final facing cancels out, which is 0. So at the end of this, we're still at 0. We're facing the same way we started. So one loop draws this little triangle thing, and then we end up here on the end of it. So just do it a total of 5 times. And there you go. That's what that will draw. It'll draw kind of a little sawtooth thingy. Okay. Now, here's a good question I like. Now, suppose I change I change what we had previously to suppose I change what I had previously, and now we have, instead of Bob and length, I had Bob and length and size. What makes this change significant? In other words, what control or power does the programmer get? So So again, if you're answering here, it draws 20 sawtooths rather than if it draws 20 sawtooths, that's not what I'm going for. I'm going for what we've added to the program in general, not the arguments over here, not the things we pass in, but over here. And we added in a size parameter where normally we were set to going at 10. Now we can basically make the teeth of this sawtooth image as big as we want. So that's kind of what, so I'm not looking for you to say, we added another thing as a parameter that can be used by the forward function. That doesn't tell me what it does. You just simply told me what the change in the code was, but you didn't tell me what effectively it does, which is that it allows me to make it bigger. Allows me to make the figure bigger or smaller if I want. Okay. So here is another one. So draw the result of the turtle program below. You can use a dot to represent a stamp, rather than making you draw a bunch of triangles or whatnot. It's a. So this one this one is about as probably as hard as a question as you could expect on the exam, which is that it has a nested for loop in it. Okay? Now, that being said, I'm not a jerk. If you haven't noticed, I named the last question something relevant. I called it Ziggy, and it kind of made a zigzag pattern, right? Similarly, over here, I didn't just give it a random variable name. I said for step. That's not a bad way to describe it, each step in that figure. Same over here, length and size. I didn't name size Fnord or some other nonsense metasyntactic variable like that. Okay. Similarly for here, oh, what just happened there? Okay. Similarly for here, let's read through this. Import, turtle, bob.penup. So again, over here, just to make it simple, we're just doing dots. For row in range 5, so I gave it a name, row, which implies, okay, this is what I do. So for each row in range, so this implies 5 rows. That should probably give us a good idea of how to do that. So for dot in range, row plus 1. That's probably the most complicated part, because what row is changes each iteration of the outer loop. So we do that, which requires us to stamp and move forward. So let's put that in the side. So we're going to be stamping and moving forward some amount. We don't know how much, okay? Okay, but then once we get to the end over here, Bob is going to turn right 90 degrees, so he's going to face this way. He's going to move 50 down. Okay, move 50 down. He's going to turn right another 50 degrees, so he's going to be facing this way now. And then he's going to move forward 50 times row plus 1. So he's going to move forward row plus 1 over here, right? He's going to move 50 times row plus 1 forward over here. See what I mean by that? So like if he moves forward, so if this value, row plus 1, is 1 total, then he'll move forward 50. If this is 2, he'd be moving 100. If it's 3, he'll move forward 150. No matter how far he moves over here, we can see since he's turned around, he'll move the exact same amount backwards. And then we turn to face this direction again. We do right is equal to 180. So 90 plus 90 plus 180, that's 360 degrees. We're facing the exact same way. We're just at the beginning of another row. Make sense? So the idea here is that we create some number of stamps on the first row, then some number on the second row, then some number on the third row, right? And we didn't actually draw anything definite, just kind of followed what the path would be. So let's go through this, though. What if you want to actually act like the turtle, right? So row is equal to 0. So over here, this would be 0 plus 1, so this runs 1 time. Bob stamp, move forward 50, so the turtle's over here. Okay, so he turns to face down, moves forward 50, turns, moves forward 50 times row plus 1. That's 0 plus 1, so he moves forward 50. So he moves over to here. And then 180. So now he's facing this way. So now we update row to be 1. So now this becomes 1 plus 1, which is 2. Okay? So do the following twice. Stamp, move forward, stamp, move forward. Turn to the right, move down, turn to the right, move forward 50 plus 50, move forward twice, or move forward 50 times 2, I should say. And so now we're here, and now we turn around 180 degrees to face the same way. So the third row will have dot, move, stamp, move, go down, turn around, stamp, move, stamp, move, stamp, move, stamp, and then finally we'll get this. So you should get a triangle like that. So notice that also the angles I give here aren't like the kinds of stuff you'll need a protractor for, right? I try to make it so that we don't really have to think too hard. Or if you're like me and your artistic skills leave much to be desired, because I'm terrible at drawing, then it's not going to be atrocious. All right, this one should be fairly straightforward for you, which is because you've had to do something like this a number of times. Complete the function so that the turtle is passed in as an argument. So that turtle passed in as an argument draws a square. Each side of the square should be sidelong. So again, you've wrote something like this before, which is just simply say for in range 4, do the following 4 times, which is Bob dot FD, that's short for forward. I'm going to use, my answers. I'll write my short, some short things. But on the exam, I'll spell it out for you because that's, again, readability is key. Side Bob dot RT 90. Right? Makes sense? So move forward, right turn, forward, right turn, forward, right turn, forward, right turn, and now we start where we end off. It's very useful. For a lot of these, I will try to make it so that if you have stuff, we try to end relatively, if not where we started, then relatively close. Okay. Using the draw square function, write a turtle program that will draw the shape below. You may create more functions if you wish, right? You can always write more functions, okay? Now, I clarify over here that this picture is 4 squares, okay? Because otherwise, we get into the question of one of those puzzles of how many squares do you see in this picture? Well, I see those tiny squares and those big squares. No, we're not overcomplicating this. We are just simply drawing 4 squares. And if we think about it, okay, how did we write this? So the turtle ended up here. That's a hint. So that probably means that the turtle started here. Right? It doesn't make sense that it would travel in and out. It makes sense to travel diagonally. So if we started here and we use the draw square function like the professor asked, then if I call draw square, I'll draw this. Okay? So then what would I need to do to do the next part? To do the next part, I'd probably want to move here to that corner, which happens to be at the center of the square, right? And then from there, I can call draw square again, and then I can just keep repeating that process, right? Once you figure out the second one, you kind of see once you figure out how you get from drawing the first one to the second one, you can kind of see, oh, okay, that's where these squares are, right? So draw the square, move to the center of the square. That's what this ends up being, okay? So not too hard to do the first part, right, which is using the draw square function, write a program that will draw this. So let's go ahead and I'm just going to write this down without even making it a function. I'm just going to say, okay, first thing I need to do is draw square. Notice I'm leaving myself plenty of space to the right and to the left and above me and below me over here. So draw square. And it doesn't really matter what I choose other than Bob and maybe I'll say 50 or whatnot. It doesn't really matter. In fact, let's go ahead and make it abstract. Bob and the amount of side it is, right? So we draw that square. So now I have to get Bob from here to there. Okay. How do I do so? Well, the way I'll do so is, first off, traveling diagonally will make your geometry teacher sad, because your geometry teacher would like you to remember that this line segment is longer than this line segment and this line segment. Going diagonally would require you to multiply by, I believe, root 2 or So there is a, there is this, remember this whole thing from geometry? Yeah, so let's go ahead and just take the long way, shall we? So, let's see. Bob dot, and I'll just use the short command here. Bob dot up, which is short for pen up. Okay. Bob dot right turn, and this will always be 90, or, you could all, there's nothing stopping you from going forward over here as well, but I like to do it this way. Okay, Bob dot right turn 90. Bob dot forward, and then we have to put in a certain amount. So this is side, right? That's how big the side is. It's side. So if I want to go to the halfway point, side divided by 2, right? Makes sense? Side divided by 2. Do I have to care about integer division? Don't worry about it, honestly. Really don't. It's that the computer will handle it automatically for you. Okay? So now we've moved to this location over here. So then in that case, let's Bob dot left turn 90 to go back to facing east, or to go back to facing right. And then Bob dot forward side divided by 2 again. And that will move Bob over to here. Right? Okay. And then we'd probably and then this is the kind of, these are the minor points over here. Like this is the really minor point over here. Bob dot down. If you forget up and down, that will change the picture slightly. The picture would look like this instead, which is a super minor point. On a 10-point question, that would cost you a point. So don't stress out about it if you forgot the up and down. But that's just simply so we don't draw the very first thing. But this draws a square and gets us to the center of it. Okay? And now we just simply say 4 in range 4 to do that 4 times. And then if I really want to do it, let's see. Then if I want to make it a function, I can just simply say def prob 13, and that will take in Bob and side. And then and honestly that would be enough, and if you wanted to call it, you could write the call down there to pass in Bob and stuff. But that's if you make it a function, that's really all I'll care about. If you forget import, what if you write your code and you forget import turtle and start doing it? I'm probably going to completely miss that, to be honest, so don't worry about it. What I care about is the actual commands. Okay? Again, what I'm testing is, I'm not trying to get you with gotchas or anything. I'm trying to understand the actual things here. Okay? All right, so there's extra credit here, but and if there's, let's see, where am I on time? Well, plenty of time for right now, so I'll come back to this one in a bit just to make sure. But this one, again, is extra practice over here. It's the same idea, just in a different shape, right? And again, what we're doing over here is drawing, 4 squares, and then that overlap each other. So figuring out, it makes sense that they kind of overlap like this, But again, getting there is interesting. All right. So this is one of those fun, annoying ones that we did that's almost completely mandatory for Computer Science 101, which is the nonsensical printing question. Foo, bar, and baz in this case, and then following your calls of stuff. And once again, foo, bar, and baz are the metasyntactical variables that are used in programming. In English at least. There's other ones that that's a real term, by the way. Metasyntactic variables. Okay? So other languages have their own metasyntactic variables. So let's see. Quick, Quux, Korg, Grulp, Garpley, Waldo, Fred, Plug, Zigzhi, and Thud. French uses Toto, Tata, TT, and Tutu. Again, it varies from language to language. And that's just simply, Python is unique, and typically in examples you'll see spam and eggs, which is a reference to an old Monty Python skit. So anyway, here though, I wrote this originally for Java, so foo, bar, and baz it is. So we define foo, it prints foo. We define bar, which calls foo, prints bar, and calls baz. And then we define baz, which prints baz, and calls foo. And if that is nonsensical to you, if that is nonsensical to you, don't worry, it's nonsensical to me as well, and I'm the one who wrote it. So then we call those functions over here. So foo, the first thing we do is we print foo. Bar calls foo. So when we get the bar, it calls foo, which prints out foo. We're done with foo over here, so then we go on to bar. Okay? So we print bar. And then we call baz, which prints baz, and then calls foo again to print out a final foo. And then we call baz. Finally, so we've done foo, we've done bar. Now we got to go over here to baz, which prints out baz, calls foo, which prints foo, and now we're done. So it's foo, foo, bar, baz, foo, foo. Okay, now probably the more important question, suppose we change baz to do the following. And that is the change in case you couldn't see it earlier. What happens if we do that? There's one correct answer and a more correct answer. So, anyone? Yes. You got to force quit it. Yeah. That is, I guess, the third correct answer. You have to force quit. You have to automatically you have to stop the program because it's not going to stop, because there's a good potential it's not going to stop. In this kind of situation, if your computer had infinite memory, we'd get to the second answer, which is that it's an infinite loop, which means it goes on forever. Bar calls baz calls bar calls baz calls baz, and so on and so forth. If you actually run this and let it run, it should actually get you a Stack Overflow error, which gets into the fact that it's recursive. But long story short, it's bad. It will break, or it won't work the way you want. It's basically infinite. It's an infinite loop, or infinitely recursive, or it's a Stack Overflow error, or you have to force quit. All are acceptable answers at this level. All right. This one, I've got confundus and confundo, and which I do warn that they're intentionally, if we get into things that are intentionally confusing, I do try to warn you that is an intentionally confusing thing. Okay? So over here we have XYZ, we pass in ZY, ZXY, and we have YXZ over here. I know, aren't I the greatest? All right, so the big thing to understand is that XYZ over here and YXZ over here are completely different. They are completely different entities. So anything that, so everything that occurs is positional. Okay? When we do function calls, everything is positional. It doesn't matter what the names are. So this, whatever's over here, doesn't matter what the name is. It goes to the first position. This goes to the second position, and this goes to the third position. Make sense? So let's go ahead and simplify this for ourselves. X is equal to 6. So I'm going to go ahead and write 6 over here. 8, y is equal to 8. So I'm going to go ahead and put 8 over here. And then z is equal to 4. I'm just going to put 4 over here. And I'm doing this and just kind of forgetting about what the variable names are because I see that this is just a function call. And I'm trying to figure out a function call. So I don't have to remember. I'm not going to use these variable names later, so I don't have to remember what they are. So I'm going to pass them over here. So that means y is 4, x is 6, and 8 is z, or z is 8. See what I mean by it's positional? It has nothing to do with the names. The names are just simply a red herring. They're a trap. Okay? So now, x is equal to x plus 1. Increment x by 1. So 6 to 7. Y is equal to y, which is 4, minus x, which is 7, plus z, which is 8. So 4 minus 7 is negative 3. And then y becomes, and then negative 3 plus 8 becomes 5. So we store 5 in y. Right? We change that one because that was y. 5, 7, 8. And then print zy is the xy. So z is 8, 7, and then 5. Right? All right. Okay. Now the answer to this one, now this is possibly even worse. This is actually even worse of a question because the answer is 17, 8, 2, and I can do that without having to solve anything. So here, what we do is we pass in x, y, z. And when you pass something in, a 17 over here, an 8 over here, and a 2 over here, what happens? To pass something in, to go from variable to variable, you copy the value. We copy. Remember, this equal sign, this assignment statement, takes what's on the left and stores it on the right. Sorry, takes what's on the right and stores it on the left. If it's in case of a variable, it takes what's inside the variable and copies it. Okay? So it copies 17 over to here. It copies 8 over to here and 2 over to here. Now, no matter what changes occur, x is equal to x plus y. So that would be 10, but that's just changing this value over here. Same with over here. Y squared, that's only just changing y over here. Z is equal to z mod x, right? Again, that's just changing z over here. Okay? So that's why the answer is 1782, because we just do these operations. They change what's in confundo, but not what's outside the function. Yes?
If the x, y, z is outside of the function, does that still change the,
If you're saying what?
If the x, y, z is outside of the function.
Like this? Oh yeah, if this nonsense was instead like right here, yeah, then we'd be doing those operations. The point of this is to teach you, the entire point of this exercise is to teach you that basically that this gets copied over here. If it's integers, we're going to be copying them. If it's the strings, we're going to be copying them. Lists, strings kind of copy it. With lists, we also kind of copy it. Kind of. With basic things like integers, what we're doing is we're copying the actual values. With things like lists, what we're doing is we're taking the memory location and copying the memory location of where to find it. It's the way all programming languages work. But again, over here, again, these entities inside the function and outside the function are completely different. Okay. Print 3. Okay, this is the last of the actual problems. Write a new function called print3s, which prints all positive integers less than limit that are divisible by 3. If limit is less than or equal to 0, print nothing. So this one is, you think from that last clause that that requires an if-else statement. It shouldn't, though, right? Because if it requires an if-else statement, we could just put it in front of all of our code. But over here, what are we going to do? We are going to say, we just need to print the numbers that are divisible by 3. Now, again, you're thinking to yourself, if you're, that we, again, that for figuring that out, we need like a for loop, go up one number at a time, and then if the number is divisible by 3, then print out that number. But again, I'm not testing you on if-else statements in this exam. Now, if that is the way you do it, more power to you, You're allowed to do it that way. I don't care so long as it works. Similarly, if you use a list comprehension and print out that's fine. Technically, even though it would be a list of numbers, you're more than welcome to do that. So you're allowed to do what you want. But for here, we're going to be making use of range. Okay? We want to print out all positive integers less than limit that are divisible by 3. Okay? If limit is less than or equal to 0, print nothing. So all positive integers, now this is just simply a technical point here. So if you mess this up, again, not a math class, but if you mess this up, 0 is not a positive integer, right? It's an integer, just not a positive one. But that's like one of those technicalities that I wouldn't really, again, it's if I were to get you for that, it's a point at most. So but this is what I would do. I would do for each number in range, right? And then this is the important part, so I'll put it in a different color. For range, and then I'll be making use of all 3 fields in range. The start of it, the end of it, and the step. Okay? So we want to start at 3, basically, because 3 is the first positive integer that is divisible by 3, right? We want to go up to, so print out all positive integers that are less than limit. So we want to go up to, but not include limit. Right? That goes up to, but does not include limit. And then, to make sure we only get numbers divisible by 3, we can just simply use the step over here to go 3, limit 3. And that would print, and then we could do print num. Okay? So that's one possible answer. Another possible answer is that if you forgot about that part, right? But you do remember about that bit that you read about if-else statements, right? You could totally do something like this. If num is divisible by 3, which we'll figure out how to do that in just a second, print num. So if num is divisible by 3, how would it be divisible by 3? We use the modulo. So again, we use the modulo operator here to check if something is divisible by 3. If there's no remainder, so if the remainder is equal to 0, then it's divisible by that number. Okay? But again, I'm not. Again, what I'm testing you on is not the if statements. I'm testing you on for loops, which means that pretty much everything you can do is usable in the range function, right? Another way to do that is, you could, let's see, one more way to do this. All the numbers, okay, and just off the top of my head, one more way to do this is 1, 2, limit, divide 3, and then print num times 3, right? Again, for a lot of these questions, there are multiple ways to do things. And that's true for a lot of questions that you'll be experiencing in the future for this class. So rather than doing the rest of the questions, I think I want to just draw your attention to more resources. So first off, I have these additional practice problems here are way more difficult than what I would put on the exam. Okay? Now over here, I just simply say Project Euler Problem 1, like you would know what that is. So, but what I would expect you to do at that point is maybe try Googling Project Euler. And Project Euler is pretty awesome. Project Euler is a bunch of math problems, a huge collection of math problems that are designed to be solved by programming. So these first two, multiples of 3 and 5 and even Fibonacci numbers, I think are great practice at your level, especially the first one. But so that's very good practice over there for that. Also on Canvas, let's see. Let me just go and see what I have on the Canvas page, because I think with the current, I think I have an in-class exercise I would normally do, but I don't know if we'll have time to do it. So I'll just simply let you know about it. If we have time to do it, great, you've got a head start on it. Otherwise, it's yet another, resource for you to use. So assignments over here. By going down to assignments, loop and function, yeah. So this one, loop and function exercises, right, which I need to adjust. But you can find it under assignments, loop and function exercises. This is an old homework I used to give. So this is a homework I used to give before, before I turned week 4 into 5 into one assignment. I had it broken up with more simpler problems, and then I had these problems. So these are good ones, although again they do rely on you knowing about like if statements a bit more. The number of vowels in a function, which given a string returns the total number of vowels. So number of even digits in a number. Detecting whether something is a 3-digit Armstrong number, which I defined there. And then this one's from a textbook problem that that we used, which is using a for loop to figure out all this, to figure out the proper 4-digit number. So that is a good kind of reference there. But overall, I would not panic too much about the exam. I will try to make it as easy for me to grade as possible, in the sense, like, again, I rely on as much multiple choice kind of reading the code kind of things that I can. If you have any questions about the exam or the like, please email me over the weekend, to set up time to meet with you. Otherwise, I think that's it for today. All right? Take care.